Hello class, we're about to pick up where we left off at on section 4.7 on page 412. It says, based on the work you did earlier, what's the probability that the next bag of M&Ms you get from a vending machine will have either 56 or 57 M&Ms in it? Briefly describe how you got your answer. So what we would have to do is to go back to this chart here. And it says 56 or 57. So it'll be basically this 13.6% as we see here. So we will put 13.6%. And then that would equal to 0.136 if we wrote it as a decimal. So basically we found the percentage in that range and changed it to a decimal. Okay, now we come down here to what is called Z-scores. As you probably know, there are two main companies that offer standardized college entrance exams, ACT and SAT. Since each has a completely different scoring scale, it's really difficult to compare the scores of students that took different exams. Number 3, do you think that scores for these exams are normally distributed? Discuss. And I would say yes, because most people score close to the mean with less as you go further from the mean. Now, one way to compare statistics drawn from different populations is to compare how far above or below the mean they are. The Z-score is a statistical measure that was designed to do exactly that. A Z-score tells you how many standard deviations a data value is from the mean. The data value on the number line above would have a Z-score of 1 because it is one standard deviation above the mean. Data scores that are below the mean will have negative Z-scores. Now we come here to the back to problem number 4. Now problem number 4 states, fill in the blanks in the diagram with Z-scores using the description at the bottom of the previous page. Okay, so basically we're looking at standard deviations. Now, if you look here, this middle value is the mean. And remember, standard deviations is how far it's away from the mean. So your Z-score would be 0. Because it's exactly on the mean. Now here, this is one standard deviation above, 2, and then 3. Here, this would be -1, -2, and -3 standard deviations away from the mean. A standardized test of intelligence is scaled so that the mean IQ is 100 and the standard deviation is 15. We'll be using these facts for the next few questions. Number 5, it says find the Z-score for a person with an IQ of 85. So if we look here, the mean is 100. Their IQ score is 85. So we would end up subtracting, but I actually put this backwards. We should take their score minus the mean, and that would give us a -15. Now remember, 15 is your standard deviation. -15, which would mean that is -1 standard deviations away. Because remember, your standard deviation is 15 above, 15 below, in that order. It says find the Z-score for a person with the IQ of 115. So we'll take their score, subtract the mean, and it's exactly 15. And the standard deviation is 15. So your Z-score would be +1. Now, let me just say this. The reason why I put these lines in here is because my z's look like 2's, but this is supposed to be a z equals to signify that my z is a z. Okay, number 7. What's the probability that a randomly selected person has an IQ between 85 and 115? Now, this is 85, a z-score of -1, and 115 is a z-score of 1. They said, what is the probability that a randomly selected person has an IQ between these two values? So we see their percentages. We add 34.1%, and we add the other 34.1%, so it'd be 68.2%, which is equal to, since we're doing probability, we'll write that as a decimal, 0.682. Now, if a data value has a z-score of blank, then half of the data are below that value and half are above. That's 0. Because remember, a z-score of 0 is the mean. Now, we know that the center of a normal distribution is the mean for a random variable. What does question 8 tell you is also true about the center of the distribution? It is also the median, because half is above and half is lower. And that is the definition of the median. Now we come here to problem number 10. Now problem number 10 states a job applicant is told that their IQ score measured in the screening process is higher than 84% of the general population. What was their z-score and their IQ? Okay, so it says that their score is higher than 84% of the general population. Okay, so this is what we would need to do. We would need to add up until we get to 84%. So we add 0.1%, we add 2.2%, we add 13.6%, 34.1%, and 34.1%. And when we add all of these up, that gives us 84.1%. So that means that we went from this end here all the way to here, which is the z-score of 1. So their IQ is 100 plus 1 standard deviation, which would be 115. So if they got a score of 115, they have a score that's higher than 84% of the general population. Okay, now we move on here to the next page. We have computing z-scores. For a data value from a sample with mean x bar and standard deviation s, or from a population with mean mu and standard deviation lowercase sigma, the z-score is, now we have the z-score. It's a score minus the mean divided by the standard deviation. So we have it for the sample, and we also have it for the population here. All right, some notes. A data point is greater than the mean if z is greater than 0 and less than the mean if z is less than 0. Z-scores have no units. Z-scores are typically rounded to 2 decimal places. All right, so we come here. It says 1 year the ACT had a mean score of 21.2 and a standard deviation of 5.1. So we know the mean of the ACT is this, and the standard deviation is 5.1. That same year the SAT had a mean score of 1498 and a standard deviation of 347. Suppose that a scholarship committee is considering 2 students, one who scored 26 on the ACT and another who scored 1800 on the SAT. Both are pretty good scores, but which one is better? That's not so easy to decide because the scales are totally different. First instinct, which score sounds better to you? Okay, well, my first instinct would be the SAT. It sounds high and is 300 points above the mean. Now number 12, it says find the z-score for each test score. So we'll take the ACT. So we add x minus the mean all over S. So the value here, the ACT was a 26, minus its mean was 21.2, and the standard deviation is 5.1. So this will give us 4.8 over 5.1. And then after we divide this out, now this is our z-score. I should have put z is equal to this. So we could put this in our calculator. We will have 4.8 divided by 5.1. So we'll round it to 2 decimal places. It'll be 0.94. Now we would do the SAT. Yeah, z is equal to x minus the mean over the standard deviation. 1800 is the score, minus the mean is 1498, all over 347, which is the standard deviation. Now when we subtract this, this will give us 302 over 347. So we'll put this in the calculator, 302 divided by 347. And then that would give us 0.87. So our z-score will be 0.87. So basically our ACT score actually turned out to be higher by the z-score than the SAT score was. Okay, now we go here to the back. Now 13, it says describe exactly what each z-score tells you. The ACT z equals 0.94 means a 26 on the ACT was 0.94 standard deviations from the mean. SAT z equals 0.87 means an 1800 on the SAT is 0.87 standard deviations from the mean. Based on the z-scores, which would you say was a better score? The ACT, because it is more standard deviations above the mean than the SAT. Okay, now come down here to a sports situation. It says big sports fans tend to love arguing, and one of their favorite type of argument is who is better, Michael or LeBron, Montana or Manning, Kershaw or Koufax. Blogs and airways are filled with arguments of this type. And what makes it so difficult to decide is that players and teams from different eras are hard to compare statistically because sports evolve. And what might have been an amazing statistic 50 years ago could be completely pedestrian today. Fortunately, this is exactly the kind of thing that studying statistics analytically is good for. The 1942 St. Louis Cardinals were an awesome baseball team. They won 106 games in an era when teams only played 154 games in a regular season. During the 1942 season, the mean number of games won by a National League team was 75.8 with a standard deviation of 20.5. Another great Cardinals team was the 2004 squad, which won 105 out of 162 games. In 2004, the mean number of games won by a National League team was 80.9 with a standard deviation of 13.6. So if we look here, this was the mean, and this was the standard deviation for 1942. And this was the mean and standard deviation for 2004. Now, based strictly on winning percentage, the percent of games won, that is, which was the better team. So we had a 1942 team that won 106 out of 154 games, which is a 68.8% won. Then the 2004 team won 105 out of 162 games, which is 64.8% won. So based on percentage won, the 1942 team was better. That's just based on percentages. Now, we move on to our last page of this lesson here, and we come to problem 16. Now, problem 16 says, use information besides the winning percentages in the preceding paragraphs to make a good statistical argument about which team was better. Obviously, showing your work is a must. Write your final answer in the form of a few sentences, showing you know what you are talking about. The 2004 team is better in terms of being the most standard deviations above the mean compared to the other teams. Look back at your answer to question 1 on the first page of this lesson. How did you do? Would you be able to come up with more examples now? So we did pretty well. Now I'll go back to that first page so we could see that. When we did the IQ scores, the first page is 405. And we wrote down IQ scores, finish times in a race, and scores on an exam. Okay, so pretty well, we can add height, weight, and candy in a package. So this basically concludes 4.7, and this is actually the last new lesson of this course. Now, From here on out, we will be doing a review for the final exam after today. So, and there is no check assignment for 4-7. Now remember, you do have a lot of things you need to complete. Like for instance, you need to finish up project 4. You need to do the homework. You need to do, well, all the check assignments should be done about now. And so you should be basically wrapping up on the last few things, including the worksheets for chapter 4. And that is basically it. Okay, class, in addition to all that I've told you with this lesson, I also want to talk to you about Project 4. I did make a quick change to Project 4, and I want you all to take a look at this. Okay, now, the original Project 4, which I pulled down here, basically had these here, which basically had you do everything on your own, but I'm going to switch this up with the new Project 4. So you could go to Projects and go to where it says New Unit 4 Project. And then in the new Unit 4 project, it has specific tasks for you to complete. Like here, Part A, it gives you specific numbers and specific things to complete. And Part B does the same, and Part C, and Part D. Now, one thing that I didn't do, and I see a little error that I'm going to correct, is this predict something here should be removed, but everything else should be fine. So you should be able to do this in lieu of the old Project 4. And it shouldn't take you that long to do it. And if you have any questions, please contact me and I will gladly answer any of your questions. Thank you.